So we know this. The definite integral from 2 to 5 of, I'll just start easy here, x squared plus 3x dx. We have to talk about the dummy. So, the dummy variable, okay? Right now, all we've known up until now is the dummy variable has to match the variable of integration. I'm going to add more to that now. This dummy, the dummy variable for us, this is going to change next year. Those of you who take Calc 3 in college or Calc 3 next year with me, this is going to change. But this dx tells you not only the variable of integration or the variable of the integrand, this unwritten but understood dx means that the lower limit of integration and the upper limit of integration are in terms of x. I mean, it almost goes without saying, okay? So what I'm underscoring here is that dummy variable, the fact that these are limits of x are important. So, for example, if you had a definite integral from x equals 2 to x equals 5, and this integrand was in terms of y dy, that does not make sense for us. So the point of all this is that all of these variables, this, like these, needs to all agree. They all have to agree. All must agree on the independent variable. So now we're getting to the place where two ideas are going to come together. The limits of integration, the dummy, and the integrand must all agree. All right. Now, we're going to go to here now. This is what's going to be new for us, okay? When we are here, yes, Oliver, was that you?
Will there ever be a time that?
That's what you just read my mind, okay? We know how to evaluate this using the fundamental theorem of calculus. We find the antiderivative, evaluate the upper limit, evaluate lower limit, subtract them, okay? How about this one? The definite integral from 2 to 5 of, okay, 3x plus 1 all to the 17th dx. Now, here is where two ideas are going to collide here. The actually three ideas, quite frankly. The idea of the definite integral, the idea of the indefinite integral, and the idea of integration by simple substitution, okay? If I look at this for a second and delete the limits of integration, do you see that u sub has to happen to integrate this? Yep. Yes, we all agree? All right. So here's what we're going to write first. I'm going to first address this. I'm going to first address the indefinite integral. In other words, I'm dropping the limits of integration to make a very big point later on. Let's first deal with this. You probably, hopefully, all agree that u here should equal what?
3x plus 1.
All right. I will meet you at the point where you have the integral entirely in terms of u. Pause there, please.
Let's say it's 17.
Yes. Okay. When you get to the integral in terms of u, meet me back on the board. Not going to rush this. Take your time. Meet me here. All right. We all good? When you are here, the dummy has changed. du is dummy variable. The integrand here is in terms of u. If I do this, look up here, please. Watch me do something. If I go up here and write this, this is the same thing as 1/3 the integral of u du 2 to 5. This is wrong because these limits of integration are in terms of x. These limits, for they to be equal, they have to be in terms of u. How do I find the requisite lower limit of integration that was x equals 2? X equals 2 corresponds to what for you? Look at this statement here. X equals 2, we use the substitution that we decided on. X equals 2 becomes u equals 7. Okay, that is what happens. X equals 5 becomes u equals 16. And now I can safely say these are equal. I'm going to do one more thing here. Do you see this 1/3 factor? I'm going to pull it out. Are you okay with that? I'm going to pull the 1/3 through.
So would it be 19?
Okay, everyone okay? Now, here is the thing, okay? When you go and evaluate this, you're going to notice something. That if I want to use the FTOC, these integrals are all equal. All I've done is I've taken a valid substitution, rewritten a definite integral in terms of x, into a definite integral in terms of u. I will meet you at the end. This is going to become, can I please have the antiderivative of 1/3 u to the 17th?
It's 1/3
Is that fair? Okay. And then we are evaluating this at, now look at my notation, 7 to 16. Without a calc, we're going to leave this thoroughly disgusting, which is fine. This becomes 1 over, I think this is 1/54 times 16 to the 18th minus 7 to the 18th. And this equals the net sine area bounded by this curve from x equals 2 to x equals 5. Some of you like to have titles. This is using FTOC when U sub is required.
Are we going to do another?
We're going to do tons more. So do you see in a question like this, there's U sub going on, there is FTOC going on, and then there's just straight up antiderivatives. Yes, Kate?
I feel like I might be limits wrong, but wasn't there a way to keep the same limits but manipulate the inside somehow?
Oh yes, sure. So here, some people do this. So watch this step. Here is your alternative. At this step right here, do you see this step right over here?
Yeah.
Sometimes people like to do this. They will say, well, I'm going to make 1/3 u to the 18th over 18th. I'm going to write this as 1/3 u was 3x plus 1 to the 18th all over 18 because I put the u back in here. If you put the u back in terms of x, what will the limits have to be?
2 and 5.
Yes. Yes, you've got to revert back. I don't have a preference. I will tell you this. I don't have a preference. I'd say between 80% of the time, it's easier to go take care of the u. It's just easier arithmetically. Oliver, question?
So if you don't use u, do you have to convert them from x to u, or do you just leave them as x?
If you don't use u.
If you don't use the, like,
If there was never a u sub involved, you're asking?
no, if instead you, so if, Kate just asked if you could use x instead of u, so you would have to use the limits as if there were x instead of u.
Yeah, Kate's method, it still requires all the same. It requires all of this, just at this juncture,
Okay.
you would jump down here and go back in terms of x. Okay, that's all. 80% of the time, sticking with u is easier. All right, let's practice this. Let's do a few of these. Ready? How about this one? The definite integral, okay, negative pi over 6 to 3 pi over 4, okay, of the cosine of 2x dx. I'm going to leave lots of room. work showed that well as practicing a whole bunch. Oh, practice so much. And then we're gonna have a big fat star. And then Megan, Estrella, Kate, you're gonna see why. Here is where I talked about why the ln has an absolute value. So I'll talk about that in a second. Okay, that one, let's do this one now. Definite integral, -1 to, let's try this one, -1 to -11. Okay, that's fine, I can go that way. -1, that's a fair integral of, let's see. Secant squared x e to the 3 tan x. Woo! Dx. Yowzers. That sounds gruesome. Ooh, I like that one a lot. Let's do this one. Let's do, I'm gonna go to the front. Okay. Yep.
Why the stuff was never, like, even without the FPOC, when this, like, it's still apply.
Yep. Right.
Oh,
Yeah.
oh, yeah. That's
Right, so what I did was I did the indefinite integration.
And so that would have just been like. Yeah, okay, I think I see, yeah.
Right, so, and that's why, so we did indefinite integration with use of. Definite integration with use of, that's, we have to add the issue of the, limits integration.
Oh.
Yeah.
That's the only thing that one has like.
Yes, the definite integral has limits integration, indefinite does not.
Okay.
Not only that, answer to an indefinite.
Are you subbing u in for secant squared x? Are you subbing u in for secant squared x?
Oh, I haven't done that.
You haven't done that yet? Oh, you're doing that one? Okay.
Very different things.
So I don't know what I'm doing.
For definite integration, you don't, because you know why? It's cancels out. Subtract upper limit minus lower limit.
Right.
C cancel.
Oh, that makes sense.
I had
So rapidly go to
I would do it for half times.
Family of anti-derivatives.
Put it in for what?
10x.
That's what indefinite
Okay.
integral is like.
Okay. never mind.
Instead, when you do
Or
it,
you split.
you got secant square and it will cancel.
Okay.
Yep.
Oh, okay.
Plus C, so it's a
That makes sense then.
All right, let's see where we're one of these juicy ones.
We'll just do this.
You do, but you're probably doing it in your head. What did you say the anti-derivative is what? Well, tell me.
No.
Oliver, tell me.
No, I didn't write anything down yet.
Okay, what did you do?
This is all very easy, like staring at me. See, the vowel's supposed to be like.
Are the bounds?
No, I'm hoping.
No, I mean like, are they supposed to be saying the numbers?
For that one, no. Okay, so-
Oh, well,
Yeah, I'll beg it back.
Who's you?
Yeah.
So you make. Try that.
Let's see how well we remember some of the interesting integrations from last class. Namely, okay. 4 to pi squared. That's just one.
Oh, I can't.
This is where Paige may need someone's notes. Remember that when we had class last time, the first thing I did was like, oh,
I'm wildly confused.
Rules of integration. Yeah. Okay, so let's share this with her. There we go. Maybe you'll look back at your notes. These kinds of questions, right? So it's really funny. So I just taught this with class because she wanted me to show the derivation of the FTOC. And so that her class has been working with the FTOC all along, but they had no idea where it came from. No, that's what she wanted. She didn't know. She wanted me to show her the derivation. She just taught her class. But her class was so much. They're just like, we've been doing that. But then Albert said, now I know where it comes from. Like in that Albert voice, which is just so fantastic. There's a little Albert, there's a medium Albert, and a little Albert.
Negative
It's an
1/2
Al in
minus
3rd grade.
I
Yeah,
saw
I
him, oh my
know.
gosh, in the parking lot, he's literally like a baby Albert.
That's Andrew.
Oh, there's an
Alan's in 3rd grade.
Oh, he's
Andrew's in
There's
6th,
three
7th grade.
Alberts.
Yes.
There's 3 Alberts, he has 2
Albert, Alan, and Andrew. Oh my gosh,
They're all the
so
same.
confused.
Yes,
They
they
look exactly the
Exactly.
same.
They literally look, yeah, they look
They're
so
great
similar.
personality.
All on the line.
They look
Alan,
exactly
It's
Alan.
just gonna be descending order.
Can't do it.
Alright, so 1/3.
Chop, chop. Yes.
Oh my god, 1/3.
The anti-derivative.
Well, no, I took it interval.
There's like so many minor details, of course, this.
Good game, you guys.
I'm gonna see this word, like, not that bad.
Did you have a hat trick that game? or-
Yeah. We had a disaster scheme.
I know, I saw.
What happened?
Oh, we did, and it's just wondering if you can evaluate it at that.
Wait,
Can you pick better numbers for the up?
No, I'm not putting better
upper
numbers, no, I'm not gonna put better numbers, no.
Okay.
It's not getting up,
There's
sorry.
10 negative 1.
I'm just leaving it.
Okay,
it's
fine.
fine.
No, I
Something bad.
Oh, you
I was looking at 10 and negative 11.
Oh,
Wait,
Arjun,
we're going
suck it up.
backwards?
Kate, tell him what you do, the numbers are nuts. Walk over and say, Arjun, fuck up, you do this. You do it anyway, Arjun.
Use the calculator.
You do it anyway.
We're missing out.
Oh,
Okay, so graphically, the definition of like graph is the area of the different outside of the in terms of in like
Net sign area.
the net side area. So what like theoretically then what is the definite integral?
I know, so I know.
And like it's the opposite for the indefinite.
I know, all these things are coming, like, what does it mean, like, in context? Like, what is the actual
Don't think
significance
about
of
it
it?
too much. Just do it.
It's way easier.
As soon as you start thinking about it, you get so
No,
lost.
no,
Yeah, honestly.
there's no, right now, so AV folks, there's no context yet, right, AV folks? Like, I haven't talked about, for example, if the units of the integrand are blank, what the units of the antiderivative be, like, we're getting there. So right now, we're still in a very procedural place here. We're still in a very procedural, just like, what does this mean in the context of like linear motion, for example? Yeah, we'll get there, we'll get
So
there.
like the number you get for that, like
That number
what is the
represents,
area?
is the net signed area
I need the curve, right?
valued by the curve.
But like outside of like the graph, what is that? It's like one back from the curve.
I know, but he's
Yeah,
saying,
yeah.
outside of this being the net signed area, what else does that mean? Like, we're not
Think
there
about
yet.
position and
I know, don't,
Yeah, because you go to like
don't tell him.
Spoiling it.
you found it like indefinitely accelerated, you get velocity.
So we're
What's
talking
the
about that one,
definite
and
integral of?
where's my technical like?
It's the same thing.
I mean,
After acceleration,
balance is negative one.
That's not four.
Two negative
You
one.
can flip it, then you negate the form.
Okay,
This is physics two stuff. I gotta know it.
Yes, that's fine.
I just told you what to check you. What do you guys get for the second one?
The first
So understand why you would use it.
I didn't know this thing for it. Well, jerk's a jerk. Because I lost points.
no desire.
Yeah, that's because what you're doing, you're just doing it in your head. Right? So you don't know that, that's why, when I first did use them, I said, very quickly, you're gonna do some of these in your head, without not knowing you're doing so.
But I feel like if I try to do you something, I'm confused more.
Change his pi squared to be the
No, Arjun, will you stop whining, Arjun? For heaven's
Gemma.
sake. Read.
For June.
Yeah, you don't need to use some. You just
I'll have this here. I'm gonna ask a question, I'm just doing a random poll here. This first one with cos 2x, how many of you were able to do u sub without having to write out the u sub? In other words, how many of you were able to fairly quickly see this is just 1/2 sine of 2x?
I mean, I can do it, but I choose to.
I did it because I wanted to do use whatever I could use, I was so confused. You would be.
How do you go to every
How do you
Remember set like worksheet where that formula?
How do you know what you know? Use that, like, is there any way to find a new form? It's like,
Well, I mean, we saw that one very popular thing to try is that like, if you have an inner function, try like that works. Yeah. That's what this is. You like you
Oh,
into
wait,
it.
I have no idea. If you put
Sorry, that's one.
I for
Yeah, the derivative of that is 3 squared x.
Yeah.
The secant x squared cancel. Yeah.
even if you put it right back.
Page number 3 is dirty. If someone wants to share with Paige what the dirty trick is, that one you can.
I don't remember.
The poster
Oh,
behind you, Arjun, behind you.
Oh, it's when you add.
I don't remember.
Was
the
there
difference.
were you
Wait,
there
it's
for
in
that?
the.
No, she wasn't, but it's also inverse tan in this, remember? Okay.
I did this part and then I did this part.
Okay.
I'm done.
Thank
So
you.
why you have this thing, you do plus 3 and then minus 3.
Okay, so you can cancel
So
stuff?
like so you have plus 3 and you will be 1 and you minus. You see how
Okay, I kind of get that.
because if you
Yeah, I
have
don't
x squared plus
quite get how you get from that step to that step. Like, what cancels?
Oh, because then you have x squared. So you have
Oh,
x squared
okay, I
plus
see.
3 and it's
And then you
the
just
same with
separate them.
this. You separate it, you have first
And
part
then you
1
have 1 minus.
this.
Okay, that makes sense.
Minus
Gotcha.
3.
Is that just like a trick you guys learned in general? Is that just, that's not something like really to do with calculus, right?
Yeah, like
Okay,
It's just kind of an
so,
algebra trick.
Can I
Okay,
have your
cool. Thanks.
attention, please?
and now
So tomorrow, here's what I'm thinking of actually. Tomorrow, is tomorrow our long period?
No, we just had our long period.
Okay. Here's what I want to do actually. Tomorrow I want to be a class where you're gonna have homework on this. I'm gonna move our quiz. Tomorrow I want to be a straight up full class period where we just do nothing but integration in all its different contexts. So basically we're gonna do a in class what our work tomorrow can be indefinite integration, indefinite with U sub, definite integration, definite integration with U sub. What I want to do is just have a day where we just practice it ad nauseum over and over and over again, okay? What I'm going to do is then move the quiz to the to the half of our long period. Does that make sense? All right? I'll look it up.
Do you want me to look?
No, not right now. But the point is tomorrow, that's my agenda. How do you all feel about that? Okay? Because this integration stuff, it takes a little bit of and Gary's asking a good question. It's like, we are still in a very procedural mode. What does this actually mean beyond area, the net signed area bounded by a curve, right? But for us to get to the next place, we want to make sure we're pretty smooth with this. A few things before we leave. Hang on 1 minute, please. What was the trick involved with this one?
What's the answer to that one?
Plus 3 minus 3.
I still think
Now, hold on, let's just split this properly. So this becomes I'm doing the indefinite integral first, okay? 1 dx minus 3 indefinite integral of 1 over x squared plus 3 dx. Okay? Now, here is the thing. Looks so close to inverse tan, if that could have been a 1, right? This is one of the tricks from last class page. And so what we're going to do, watch, you ready? So this becomes minus 3, okay, this becomes the indefinite integral of, now look what we're going to do inside here. This becomes, okay, 1 over, now look what's going to happen. Factor a 3 out, I get x squared over 3 plus 1 dx. And Paige, you weren't here, but I said like, some of those interesting integration methods, like some of the really wacky, wild, dirty algebra tricks you're never going to see. But what I said was work in the integration packet, pulling it out every now and then, it's just great. It's a great thing to work on together. Shreya, you add Paige to your group test. Because Paige, last class, they all created like a group thing.
I can add
Okay.
Oh,
Oh no, I don't care.
Are you
I'm not done.
4, 6, you ready? 8, 6, 2, 9?
Yeah.
This becomes, watch please, this becomes 1/9 antiderivative of 1 over x squared over 3 I'm gonna write it as, hang on a second, Nancy, x over root 3, all of it squared plus 1 dx. And
What? I don't know what's happening.
3 divided by 3 is 1.
Okay, I'll just write on this what they have on the board.
Sorry. Minus 1, okay. Then simple sub, let u equal 1 over root 3f, which is right here, and you get inverse tan. Okay?
Wait, how'd you get to that second step? Like, what is that step?
Okay?
It's this step.
Yeah.
So you got this thing, this thing, kind of.
Yeah.
Like, so you just divide like she factored 3 out, you're like just divide 3. So you got x squared over 3 plus 1 for the.
Okay, they factored a 3 out of what?
Yeah,
out of this and put it out here.
Yeah, you factor 3 out of like this.
This part and put it there. Okay.
X
And then like
minus
this.
the inverse tan of 1
How did they
over
factor the 3 out if it still has the 3 there?
1 over root 3
Oh, like you like this 3 come from the top.
Oh, it came from the top. Okay, cool.
Do the u sub, Arjun.
Okay, I got it. All right, thanks.
Tomorrow, are we all
God,
clear
I'm so
what tomorrow
bad
will
at
be?
this. Okay.
No quiz, integration ad nauseum, like ad nauseum. Like
Great
all it's just ad nauseum, like when you're modification.
I was like, shocked.
Yes, Ryan.
Oh, mine is
Mr. Hogan. Oh, no. No. Jason, you're so funny.
I just heard your laugh.
Paige, I hope I didn't weird out that class too much.
it was.
They must think I'm so weird.
No, they thought it was funny, I think.
Yes.
Do you know that song lyric that goes, the yam is the power that beats?
No.
Yeah.
I
By
have to,
Kendrick Lamar.
okay, I'll have to look it up. It's the yam is the he spells it the I am. That's my anthem.
Okay.
You can like put that on